Make it meaningful and understandable at the same time. First of all, I'd like to offer you some brief information about glass fiber reinforced plastics. Then I'll talk about PA reinforcements, hydrolytic resistant PA reinforcement and its development, and then I'll make an evaluation and finalize my speech. Before going into further details, I'd like to talk about the production of glass fiber in general. This will be brief. Our production process is as follows. This is the shortest summary possible in the table, what you see. So e-glass formulation requires certain proportions. So the raw materials are first fed into our kilns. In the kilns they are melted at certain temperatures. They enter certain chemical reactions and we end up with glass compositions. This takes us to the bushing process. This is actually a filtering process. It's like a strainer, and they will reach a certain fiber form at a certain thinness. And once they reach this stage, they will have hydroxy groups in them, which will be prepared for reactions. Later we have the bonding application, which is the heart of the process for us. Here we have silane-based organic materials, and with the glass fiber, this is going to be the bridge for the matrix, and it's going to have this chemical composition. Based on the properties of the desired end product, the bonding agent is entering a reaction with the hydroxyl groups, and in the matrix they reach the final state. This can be multi-end or single-end mats or filters, and then they will reach their final state. This is from our direct chopping group. So as I said, the bonding, the adhesive, is the heart of the process. Why is it so important? The content of the bonding agent is mainly silane, film agents, lubricant, anti-static agent, and additives. The usage area will define the formulation to be chosen. It's applied into the glass fiber and it is made harmonious with the matrix. Otherwise, the glass fiber is going to not have complete integration in the composition. It is only be a filling, and the desired end result will not be reached, especially the mechanical strength will not be reached. So if you have a harmonious matrix and a harmonious bonding agent, as you can see in the photos, it's going to be joining the fiber and it will reach the desired levels. Here you can briefly see that the reaction between the bonding agent and the glass. The reactive ends are going to enter a reaction with the hydroxyl groups on the surface of the glass, and the active ends are going to form, and in the coming processes of our clients, the final results are going to be reached. In the CTP composite, the glass fiber combines with the plastic matrix, and we reach CTP composites. In the screen you can see some forms which show you the surface of the fiber is covered by the bonding agent, and based on the processes they get composed, they get integrated, and the final composite form is taken. Here we have plastics also entering the process. They're polymer based, they can be formed based on heat and pressure, and they're usually organic substances that are petroleum derivatives. They are light, they are easily processed, they have a high corrosion resistance, they are conductive in terms of they isolate electricity and heat, and they are lower cost as compared to their alternatives, so they have a large span of usage that involves electricity, automobile, aircrafts, etc. Plastics are two ways, thermoplastic or thermoset. They can be reprocessed over and over again, they can be formed over and over again. Thermosets, once they are formed, they will not be recycled again, they cannot be recovered. In the sector, thermoplastics have a share of approximately 30%. Thermosets have a share of 70% in terms of their usage in the market. Thermoplastics, well, let's look at product groups and products based on thermoplastics. We can see that short fiber thermoplastics, which is chopped glass fiber, has a share of 81.30%. This is the highest level, so it's the most commonly used in the plastic sector. Thermoplastics these are the stages of processing. We have two processes, extrusion and intrusion. In extrusion, the plastic, well, if it's reinforced along with glass fiber, it is fed into the extrusion machine, and based on the structure of the polymer that is used at the relative speed and temperature, it is processed and then chopped and turned into granules. At the next level, there will be the injection. In the injection level, well, since I talk about glass fiber here, I will talk about fiber again. Here the polymer and fiber is going to be fed into the machine. There will be an injection process. It will become homogeneous after the mixing. Then it will be put into the final mold and it will reach its final state. The polymers that are used in the production process will be at different temperatures, as I discussed earlier. At these different temperatures, well, these are going to vary based on the type of polymer that was used. In the chopped glass fiber in the production of thermosets, PP and PBT and PA are used. The other products will have a share of 12%. 42% is the polymer system here in this table. PA reinforcement, this is mainly called nylon in the market. It has a high mechanic resistance, a high degree of corrosion resistance. It has a high upper temperature limit, so it's very preferable. It's used in automotive, white home appliances, construction, and furniture sectors. Polyamides, due to their chemical structure, are hygroscopic, so they are moisture absorbing materials. As you can see on the table, when compared to PET and PBT, nylon 66 has the highest degree of moisture absorption. This is a disadvantage, especially when the moisture temperatures are above 60 degrees. There will be a change on the color, staining on the surface. There will be a bonding weakening in between the polymer matrix and the reinforcement. So these are all the disadvantages. To overcome these disadvantages, the idea is to increase the ratio of glass fiber, because this is going to lower the moisture absorption. But 30% is the most commonly used ratio for glass fiber in the sector, and this is why this is not a very preferable choice. Which is why this, in order to eliminate this effect, we have developed a product for chopping. It's going to enable a resistance for hydrolytic, for being hydrolytic, and it's going to overcome the competition. This is most commonly to be used in the automotive industry, especially for radiators and those other parts that are subject to temperature, to high degrees of temperature and pressure at the same time. When we were starting with this project, we had two approaches. First of all, we would do the characterization of our raw materials and the bonding agents, and then we would do the characterization of the composite. So we would think about the measurement of the contact degree, the surface tension, FTIR analysis. We used our lab for this, and the analysis of the particle size. For the characterization of composite parts, we use test devices for impact resistance, and we also the test devices for bonding and tension. In the hydrolytic performance evaluation, at 50% antifreeze, 50% distilled water environment, at 135 degrees centigrade, we had a test that lasted 1,000 hours at an interval of 0.5 to 0.3 bars. Here, one of our beginning points was the hydrolytic resistant chopping product in the market, a PA reinforcement. Well, we have a comparison with the existing available products in the market and PA2D, which is our product. So when we looked at the chemicals, we started from the starting points, and we tried to receive faster results. We also looked at the mechanical performance of our existing product. At the beginning, the values were close to the competitors' values, but after 1,000 hours, we found out that we were much lower when it was compared to the competitor. This was expected. Later, we looked at the goals regarding the product to be developed. It needed to be in line with the environmental norms and human health norms. It needed to be harmonious with E-class and PA66. It needed to have a high hydrolytic resistance. It needed to be easily processable and hydrophobic, as well as with the desired chemical and physical properties. We worked on this project for approximately 1.5 years. At the end of the project, we received significant results. You can see that on the table the results of our project. Our product at the beginning had the same values as our competitor, but the 200-hour performance was leaving behind all the competition. And you can see this clearly in the coming slides. At the beginning, PA2D product, PAHD, our newly developed product, and the competitor were with more or less the same results. But after 1,000 hours, we could see that our product was significantly better. The hydrolytic resistance is a process. You should consider the entire process rather than the beginning values and the ending values. It has to do with the performance in the meantime. So these photographs will show you the situation at the end of 1,000 hours. A shows the first slide. This is our general purpose product. The binding agent, the bonding agent, the link between the bonding agent is gone, and it is now a filling agent. But the hydrolytic product, at the end of the 1,000th hour, is still within the matrix and with perfect composition. When we look at the hydrolytic performance, we will see that the choppy strength is seen here at the end of 1,000 hours. You can see the HD product performs much better at starting from 200 hours. There's a peak, and then it's going to remain high for a longer period, then it falls. The same trend is also true for azote unnotched impact. And finally, in tensile strength, similar parallel behavior is seen. So, result and evaluations. At the end of the project, we have seen that as compared to the closest competitors, we have a superior mechanical performance by 5 to 15%. And at the moment, our important clients in Turkey and abroad are at trial stages. We have already worked on this. The results were repeating themselves, and this was very positive. But this is a process, and we also get results from our clients, which are all positive. With the new generation PAHD in radiators of motor vehicles, a desired performance is going to be reached. Also in other challenging parts, we believe that we are going to be able to respond to the needs. This was all I wanted to share with you. If you have any questions, I'll be happy to answer.
So Polypropylene was mainly used in the past with the LED technique and other techniques. We use it with polypropylene. This PA2, is it HD? PAHD, okay. It's with high resolution. It has a high resolution product. And what is the difference with PP and why? Instead of, why are you going to choose to use PA? PA is a little bit more, as for mechanical performance and resistance, superior than P. The results that you will get with PA and the results that you will get from PP will be quite different. Because with the materials that has PA, you will have a more high mechanical resistance. I have another question. It's not direct with your subject. Polyester, polycarbon, polystyrene. Which glass fiber would you use for these types of materials? In our product portfolio, we have PPT, PA products, and our product manufacturers are doing it. So for PAG and as for polycarbon, testing is done upon request, but we can actually make a research and development study together with you valuable clients. For PVC, I have given PA2. Is it true? Is it right? Personally, PVT will be much more coherent, I suppose, because polyvid is not very coherent with chloride. I would prefer PVT. Especially the PVT product of ours is working in different matrices. We know that with polycarbonates. And Bayer is constantly using our PPT product in abroad. PPT is also used as well in polycarbonate, and we have the results for that as well. In the country, the same thing is valid. So the PPT product of ours within this performance can be used for polycarbonate. In PVC as well. And it depends on how to use it and the utilization. And when they use it, you can make a feedback actually, either negative or positive, and we can actually make our improvements in our studies. Thank you. May I ask a question? First of all, thank you very much. I would like to congratulate you. It's a very important subject. Just after actually boiling, there is a resistance, especially which is in the radiators of the cars. PA2, it is actually very much liked. PVA is a very well actually composition that we know that. And I can also estimate what the competitor's product is, and it is has a more better effect actually on the materials, I suppose, compared to the competitors. And we need to actually promote this product so that it can be disseminated, because the radiators are still again been made out of these polyamides, and that is the reason why your studies accordingly towards it should be well known. I just wanted to emphasize this. I didn't want to ask any questions, but I wanted to thank you for the studies that you have made so far for this.